Welcome to the lecture series on time value of money, concepts and calculations. In this lecture we will cover future value. The future value, which is designated as FV, is the value of a current asset at a specified date in the future based on an assumed rate of growth over time. The FV calculation allows investors to predict with varying degree of accuracy the amount of profit that can be generated by different investments. The amount of growth generated by holding a given amount of cash will likely be different than if that same amount were invested in stocks. So, the FV equation is used to compare multiple options. What is future value? Future value is the value of an asset at a specific date. It measures the nominal future sum of money that a given sum of money is worth at a specified time in the future, assuming a certain interest rate or more generally rate of return. Future cash flows are compounded at the rate of return, and the higher the rate of return, the higher the future value of the cash flow. Now, let us see this timeline which shows up to 3 years. At 0 time rupees 100 is invested. Now, we want to find out what will be its value at the end of 3rd year. Now, at the end of 3rd year here, the future value of this sum 100 rupees will be 133.1. This value is dependent on the rate of return. If rate of return will be different, this value will be different. This table shows if the rate of return is 5%, the value is 115.7625. If the value is 7%, this is 122.5043, the future value. If it is 10%, it is 133.1. If it is 20%, it is 172.8. So, this future value is a function of this rate of return as well as the time where we are calculating the future value. For this, the equation used is FV is equal to PV into 1 plus I to the power n, and for 10% return, if I calculate this value, this is 100 into 1 plus 10 by 100 to the power 3 is equal to 133.1. Now, the future value problems can be divided into 4 type of problems. The future value of a single amount. Here in the timeline, at 0 100 rupees invested, this is a single amount. I want to find out the future value of this at the end of 3rd year. So, here PV is what? The second is future value of a multiple constant time spaced amounts. Here we see that at 0 I am investing 100 rupees. At the end of 1st year I am again investing 100 rupees. At the end of 2nd year again I am investing 100 rupees, and at the end of 3rd year I want to know what is the future value of all these 3 amounts. So, the future value of this amount has to be found out, future value of this amount at the end of 3 year has to be found out, and future value of this amount at the end of 3rd year has to be found out. And when I add these 3 values, the total future value of this cash flows will come out. Third type of problem is the future value of multiple variable time spaced amounts. Here the amount, the value of amounts are changing. Like at t equal to 0, the investment is 100 rupees. At the end of 1st year, the investment is 120 rupees. At the end of 2nd year, the investment is 130 rupees. So, though time space is same, that is 1 year, but the values are different. One is 100, another is 120 and another is 130. Such type of problems has to be solved by the original technique and not by a equation. The fourth type of problem is future value of multiple variable amounts, variable time spaced. Here the value of the amount is also changing and the value of the time is also changing. That is, here at 0 time I am investing 100 rupees, at the end of first year and 120 rupees, at the end of third year I am investing 130 rupees. It is not the end of second year, but it is end of third year, and I want to find out what is the future worth of all these 3 investments at the end of 8th year. The last 2 type of problems which we have discussed now can be solved by equations. It has to be solved by first principle. The future value of a single amount, this is FB is equal to PB into 1 plus I to the power n. Compounding is the process of translating a present value into a future value. So, I am moving from 0th year to 3rd year, I am moving in this direction, and this is called compounding. Now, let us take a problem, small problem. What is the future value of rupees 500 deposited today after 5 years? A part, if annual interest rate I is 15% and compounding is annually. B, with the same interest rate but compounding quarterly, with same interest rate but compounding continuously. Now, the solution is that my formula is FP is equal to PB into 1 plus I to the power n. This formula is used for when compounding is annually and not compounding quarterly, which is discrete compounding, or compounding continuously, where PB is equal to rupees 500, I is equal to 15%, n is equal to 5, and I have to calculate what is the FV, that is final worth or final value. Finding the final value of a single cash flow when compound interest is applied is called compounding, and this is the reverse of the discounting. The FV shows the value of amount at a future date in commensuration with the purchasing power of the date. Now, FB is equal to PB into 1 plus I to the power n is equal to 500 into 1 plus 15 divided by 100 to the power 5, that comes out to be 1005.68. That means, if I am spending 500 rupees today, 15% interest rate, then at the end of 5th year I will have a sum which will be 1005.68. Note, FB is more than money available at the start of first year or the start of 0th year basically. This happens when we move to future. The part 2 is PB is equal to 500, n is equal to 5, m is equal to 4, and I equal to R equal to 15%. Now, this is a discrete compounding problem. So, my equation changes, FB is equal to PB 1 plus R divided by m to the power mn. This is the equation from discrete compounding. So, FB is equal to 500 into 1 plus 15 by 100 into 4 in brackets, and then overall I have 4 into 5, the power is 4 into 5, that is 20, which comes out to be 1044.076. Now, in the C part the compounding is continuous. So, again the equation changes, PB is equal to rupees 500, n is equal to 5, R is equal to 15%. So, FB is equal to PB into e to the power R n, which is 500 into e to the power 0.15 into 5, which comes out to be 1058.5. Now, from here it is very clear that annual compounding gives a FB value which is lower than the discrete compounding, and discrete compounding gives a FB value which is lower than continuous compounding. So, please note that the future value of rupees 500 in part C is greater than part B is greater than part A. Now, derivation of future worth of an annuity A for annually compounding. Now, this derivation I have not gone for detailed derivation because this derivation is a small one. If I use the future value is equal to present value 1 plus I to the power n, and if I know the present value equation, then I can put this and find out the future value. So, f b is equal to a into 1 plus I to the power n minus 1 divided by I in the brackets 1 plus I to the power n. This, when it will be multiplied by 1 plus I to the power n, this gives you future value, because this equation is for present value and future value is equal to present value into this. So, this is for present value. When I multiply this with this part, this gives future value. So, future value is equal to a in brackets, in small bracket 1 plus I to the power n minus 1 divided by I. So, this is future worth of annuity for annually compounding. Now, here the investments are like this. In the first year I have A at the end of first year, at the end of the second year I have again A, and at the end of the nth year I have again A. So, you will remember this one. For this type of investment, this is valid. I am not investing at t equal to 0 here. So, this equation has been derived for such type of investment. Future worth of annuity A for annually compounding is this, and future worth of annuity A for discretely compounding can be calculated based on this. To get the formula for future worth of an annuity A for discretely compounding, replace I in FB equation this of an annuity for annual compounding by I by M, and replace N by M into N. So, if I do that, the future worth FB is equal to this A into in brackets 1 plus I by M to the power Mn minus 1 brackets close divided by I by M. The above formula is valid for the case when number of payments is equal to number of compounding periods. This has to be remembered. This formula is derived based on this assumption. It is valid for the case when number of payments is equal to the number of compounding periods. Now, let us see the derivation of the future value of an annuity A for continuous compounding. Obviously, we are not deriving it from first principles. We are using the equation this FB is equal to PV e to the power Rn. Now, this is for PV part of it. So, PV can be written A into e to the power Rn minus 1 divided by e to the power Rn in brackets e to the power R minus 1, and when we multiply this part with this and this cancels out. So, FB is equal to A e to the power Rn minus 1 divided by e to the power R minus 1. Here also you will see that the investment is done like this: at the end of first year the first investment, end of the second year the second investment, and end of the nth year that is another investment A. This is a problem which is given in example 2. It is related to future value of multiple constant equi-time spaced amounts. Here basically the future value of an annuity is being calculated. The example 2 is a cash flow consisting of rupees 10,000 per year is received in one discrete amount at the end of each year for 10 years. Interest will be 10% per year compounded annually. Determine the future value at the end of 10 years. So, what is demanding that at the end of first year 10,000 is invested, at the end of second year 10,000 is invested, at the end of third year 10,000 is invested, so on so forth up to the end of 10th year, and at the end of 10th year we want the future value. So, the future value of this, future value of this, future value of this, future value of this, and future value of this amounts are to be added up to find out the total future value. But this can be done using a equation also. So, here the cash flow each year up to 10 years is rupees 10,000, interest rate is 10% per annum, n is 10 years. So, future value is equal to A into in brackets 1 plus I to the power n minus 1 divided by I. When I put values into this equation, this is A is 10,000, 1 plus I is 10% to the power n, n is 10 minus 1 divided by 0.1, this is the value of I, then it becomes equal to 1,59,374.25. The cash flow over 10 years is about 1 lakh. Please note that the total cash flow in 10 years is less than the future worth. Future value of multiple constant equi time spaced amounts. Question 3, a cash flow consisting of 1000 per year is received in one discrete amount at the end of each year for 3 years. Interest will be 10% per year compounded annually. Determine the future worth at the end of the third year. Now, solution based on first principle. We will do both solution based on the first principle and then using the equation. Solution based on the first principle gives you insight how the problem is solved. Now, what is with us is that cash flow per year up to 3 years is 1000, that means at the end of first year 1000 is paid, end of second year another 1000 is paid, and the third year another 1000 is paid. So, if I find out the future value of this 1000 which is paid at the end of second year, it is there for 2 years. So, the future value at the end of first year is 1000, 1 plus 10 by 100 to the power 2. This 2 is because it is invested for 2 years, not for 3 years. If I invest here, then it will remain for 3 years, but investment at the end of first year it remains for 2 years. So, this is 1210, and which has been invested at the end of second year, it remains for only 1 year. So, this is 1000, 1 plus 10 divided by 100 to the power 1, it is 1100, and what has been invested in the third year, it remains for 0 year, and hence this is 1000 only. When we add these 3 up, then it becomes rupees 3310. So, what we have done? We have found out the future value of this amount, we have found out the future value of this amount, we have found out the future value of this amount, and we have added them together to find out the total future value. The same can be done through this formula. The future value is equal to A in brackets 1 plus I to the power n minus 1 divided by I. When I put my values here, then it comes out to be 3310. Let us take an mixed problem, which is example number 4. Mr. and Mrs. Sharma wish to create an annuity for their daughter so that she gets a sum when she goes to university. They wish to invest into an annuity of rupees 2000 per month for 4 years, so that she gets the sum after 4 years when she will be requiring it. What is the future value of the annuity given that the current interest rates are 9% per annum? Now, here basically is investing per month and interest rates are in annum. So, this is a problem of discrete compounding, and hence the formula which will be used for this case is this. This is a formula for converting annuities to future value when there is a discrete compounding. So, here A, that is annuity, is 2000 per month, M is equal to 12 because there are 12 months per year, interest rate per month is R by M is equal to 0.09, which is the value of R divided by M, which is 12, it comes out to be 0075. Number of periods is equal to 12 into 4, which is 48 because there are 4 years and M is 12. So, M into N is equal to 48, and what is the value of F is demanded. So, if I use this equation and put my values, then it comes out to be 1,15,041.41. So, this means if 2000 per month of annuity is paid for 4 years at an interest rate of 9%, it will grow to 1,15,041.41 at the end of 4 years. Example number 5. This is related to continuous compounding. A cash flow consisting of 10,000 per year is received in one discrete amount at the end of each year for 10 years. That means, at the end of first year I am getting 10,000, at the end of second year I am again getting 10,000, at the end of third year again getting 10,000, likewise I am getting up to 10 years. Interest will be 10% per year compounded continuously. Determine the future worth at the end of 10th year. Here the cash flow each year up to 10 years is 10,000. Interest rate R is 10% per annum, N is 10 years, compounding is continuous. So, future worth for continuous compounding is this value, that is A in brackets e to the power r n minus 1 divided by e to the power r minus 1. So, when we put value on this equation, this is 10,000, the value of A is 10,000 and this is e to the power 0.1 into n is equal to 10 minus 1 and divided by e to the power 0.1 minus 1, it comes out to be 1,63,379.86. The cash flow over 10 years is only 1 lakh. Please note that the total cash flow in 10 years is less than the future worth. Now, this is a problem for future value of multiple variable equitime spaced amounts. Here the amount is changing. So, it is example number 6 and such type examples are to be solved from first principle. A cash flow consisting of 1,000, 1,500 and 2,000 per year is received as discrete amount at the end of first year, second year and third year respectively. Interest rate is 10% per year compounded annually. Determine the future worth at the end of the third year. So, what we have to do, this is the timeline in which investment is shown. At the end of first year this is 10,000, at the end of second year this is 1,500 and the end of third year it is 2,000, and what I am supposed to find, what are the future value of these 3 investments at the end of third year. So, the future value of the amount received at the end of third year is 2,000. So, it remains 2,000 because there is, it will not earn any interest because at the end of third year this amount is there. Now, at the end of second year this will earn interest for only 1 year. So, this is 1500, 1 plus 10 divided by 100 to the power 1 is equal to 1650, and the investment which is done at the end of first year, it will earn interest for 2 years. So, this is 1000 into 1 plus 10 divided by 100 to the power 2, this is 1210. So, if I add up these 3, 2000, 1650 and 1210 here, it comes out to be rupees 4860. So, the combined future value of all these 3 investments is 4860. Now, let us take future value of multiple variable amounts in variable time spaced. So, here the investments are different. Here the investment is 1000, 2500 and 5000, and they are 2 also invested at different time. It is at the end of first year, this is at the end of 6th year and this is the end of 8th year. So, they are not uniform. So, such type of problems are done using first principle. So, given cash flow in first, 6th and 8th year are 1000, 2500 and 5000, I is equal to 10%. So, the future value of the amount received at the end of 8th year is 5000. Because I am finding out the future value at the end of 8th year. So, whatever investment which is done at the end of 8th year will not draw any interest, and that is why that value 5000 remains 5000. At the end of 6th year my investment is 2500. So, it will draw interest for 2 years, 6 to 7 and 7 to 8, and that is why the future value will be 2500. into 1 plus 10 by 100 to the power 2, which comes out to be 3025. And the value which has been invested at the end of first year will draw interest rate up to 7 years. So, this is 1000 into 1 plus 10 divided by 100 to the power 7, which comes out to be 1948.7. So, when I add up the future value of all these 3 investments, that is 1000, 2005 and 5000, this is the value I get is rupees 9973.72. Thank you.